Okay, class, this is number 44. Sucrose, which is commonly known as table sugar, reacts with dilute acid solutions to form two simple sugars, glucose and fructose, both of which have the formula C6H12O6. At 23 degrees Celsius and at 0.5 molar hydrochloric acid, the following data were observed for the disappearance of sucrose. So is the reaction first order or second order? Now, what we're given here is a time versus molarity, and you can see how the concentration decreases as you continue with the minutes of the reaction. So how would we figure out whether a reaction is first order or second order? Well, in terms of reaction orders, if I have a first order reactant, okay, then I'm looking for a straight line when I have time, when I have time versus, now it's not concentration, but the natural log of the concentration. I'm looking for a straight line with this. If it's second order, that's first order by the way, if it's second order, then I'm looking for time, a straight line for time versus 1 over the concentration, like that. That's a little a inside the brackets. There we go. Good enough. So what I'm going to do then is I'm actually going to graph the values for, if I'm gonna, I already have time, I have concentration, so I might as well do the natural log of the concentration here. And then all I do is take this number and put it in my calculator, 0.316, and then hit natural log, and I get a negative 1.15. That's fine. And then I'm going to switch colors and go to blue so that I can show you 1 over concentration of the reactant. And if I do 0.316 and 1 over, that gives me 3.16 5, like that. Okay, so if I do that 5 times with all concentrations here, I notice that what I end up with then is a set of values that I can then graph. So the next one is a negative 1.295. You see what I'm doing here? And then for 1 over A, 1 over is 3.650. Okay? I go through all of this to get these values for 3 more calculations of that, and then I graph. So what I'll do is I will graph for the natural log, I will graph this one here and this one here, and we'll see what the graph looks like. If it's a straight line, I can stop because then it's first order. Or I'll graph obviously the time here and this one here, and then I'll see if that's a straight line, the 1 over A. So whichever one, I only have to graph one, because if it's not a straight line, then it must be the other one. So as I go through, what I notice is, and I can show you this on the next slide, is that the natural log of A is the one that produces the actual straight line. So take a look at what we have next door here. So here I have my time, and then that's the concentration, and here's the numbers I just put up. So 39, negative 1.295, 80, and negative 1.435, and 140, and so on. And that gives me a straight line for the natural log. Okay, that's not a straight line, but the straight line is already there. So that means that here I have a first order. Notice that my second order is not straight, so it must be a first order reaction. So when I come back to the question here, the answer is first order. What's the rate constant? That's the next question. If we know it's first order, sorry, I'm flipping the page to get to where I want to go. If we know it's first order, which it is, then k is just the negative slope then. So that means that I'm going to take k equals the negative slope of the straight line for the first order. So you guys know that slope, when we have points, is equal to rise over run, which means y2 minus y1 over x2 minus x1. And that should give us the slope. This whole thing here is going to be a negative. So that means that if I do that like that, using the slope equation, one of the points I can use is this one here. Where are we at? That's not the right one. I don't have this one up here. 29. Let me just take the next one here, 0.238 natural log 435.190 natural log 1.661, and the last one is 0.146 natural log. There we go, 1.924. So what I can do is take this as my, where are we at here? This as my y, this as my x. So this will be y2, and this one will be y1, and this one will be x2, and this one will be x1. So that means that I'll do the negative 1.924 minus a negative, where are we at here? 1.295, like that. And then 180 minus 39. Like that. Okay. So that should be, how did they get 171? That does not look right. So I'm just going to do what I got here. 1.924 minus 1.295 equals, divided by 180 minus 39 equals, oops, I went too far there. All right, I know I'm killing time here. All right, I'm just going to do it one more time. 924 minus 1.295 equals that, divided by 141 as my time. I get 4.46 times 10 to the negative third. And that's in minutes, or 1 over minutes minus 1. That's my K. Okay, that's it. We're done.